Hello, CS4740 Cloud Computing students. Neil McGee here. Another brief little how-to video. This is on just using basic package managers, and not everybody's familiar with this, and it might seem or sound a little scary, but it's really easy. So you basically have a few large families of Linux distributions. The Ubuntu / Debian family of things. You have the Red Hat CentOS sort of flavor. You have some other wild variants. In the Docker world, we have these really minimal distributions. One of them is called Alpine. And each one of them comes with its own sort of flavor of package manager. And a package manager is just a way that you install and maintain software as distributed by the builders of that distro. So I want to walk through how to use the three main package managers. So there's, in the Ubuntu family, there is apt, A-P-T, or aptitude is the long name for it. In the CentOS Red Hat world, you have yum, which is really common. And then in the Alpine world, and kind of becoming a little more common because it's pretty simple to work with, I think that's actually getting rolled into Ubuntu, is a one in Alpine called APK. I guess that's the Alpine package something, commander with a K. So let's just use Docker here and spin up 3 different containers, and I'll show you how to use the 3 different package managers. Really simple, basic sort of stuff. But we're just going to go ahead and say Docker run, and I'm going to run in interactive TTY mode, so -IT, and run Ubuntu. I want to, because I'm in interactive mode, I need to give it a command to run. So I'm just going to say, hey, give me a shell, run bash. And here we are, we're thrown into it. If I say uptime, I'm going to see the uptime of my host. This is actually the load average of the host machine. So this is this big iMac. I could even do top. I could do, no, I can't do HTOP. Okay, so maybe I'd like HTOP in here. So in the Ubuntu world, aptitude, APT, is ready to go and installed. However, you're going to see if I say apt install HTOP, it's going to not find it. It can't locate it. And that's because the apt repository, the apt registry, or whatever it's called, is not populated. So what I have to do the first time I have instantiated a new EC2 instance or a new Docker container or whatever is I need to apt update. And this is just going to refresh all the libraries of packages. It's basically the universe. It's a bunch of JSON and YAML files, I believe, that just show me what's available. And now I can clear this, and now I can use my up arrow keys and I can install HTOP, apt install HTOP. There we go. It's suggesting some other packages that are commonly installed with it, lsoff and strace. But I now have HTOP ready to go, and it's showing my 8 cores, my memory usage. Again, all this is not specific to the container. This is all my host machine outside of the container. I could say apt install JQ, and usually when it contains a bit more than like a meg, I'm not quite sure what the breakoff is. It's going to ask me yes or no. You'll notice that when I installed HTOP, it was so small, I just installed it. But when it's something a little bit larger, with some dependencies getting installed, it's going to ask me yes or no. And so I have to know, I have to be here with the screen to interact with this and say Y or say N. I'm going to cancel out of this and actually show you a way to install non-interactively. So that was interactive where I have to be here and I have to hit things. If I want to be non-interactive, I can just give it the -Y flag, which says whatever prompts come up, answer yes to them. Okay, so here we go. And now it just does it automatically. And I now have JQ. So it's really important to know that interactive, non-interactive mode for a package manager, because one of the best uses of bash or shell commands at all is when you're bootstrapping EC2 or you're building a Docker container. You want to be able to inject things in here, and you're not going to be around to hit Y or N. So you need it to happen automatically and seamlessly. So the other thing I'd show you maybe in apt is you can search. So let's say we're going to search for Python 3. It will search that library of everything I found. It's going to find a lot here, I'm pretty sure. And it's going to give me a big dump of values that relate to Python 3 or have Python 3 in the name. So let's see what comes up here. So it's doing a full text search on that entire index. Okay, and we're back. That actually took about 2 minutes. So that's a lot of results coming for Python 3. You can see the Zope library, Zagar library, the Xstatic, XDO. So this is really super, super long. And I could say, apt install Python 3, and that'll give me just the core libraries. But of course, that's going to have a lot of dependencies. And we can see here, it's going to give me 3.8 as my current version. So no, I don't want to continue that. So the searchability is pretty useful. You're going to see things, and you can see whether it's in the official repositories or not. One note, and this applies not just to Ubuntu, but to the other distros as well. This isn't the only way that you can install software. You should be really aware of that. You can always, from certain packages, they'll say, hey, download the source code here, and they give you a tarball, and you can grab it, decompress it, and load it. And chances are, well, maybe you need GCC, and maybe you need to compile it locally to make sure it runs on your particular chip. Maybe it's already a binary that's like a universal binary, and it's ready to go. That's fine. You could always grab things from elsewhere and build them yourself, and install yourself or make yourself, and so on. And that's usually a lot more bleeding edge, a lot more unique tools that are maybe homegrown or that some other organization has done. And usually, when a tool becomes popular or widely distributed, then the distributions will sort of pick it up, and the Ubuntu team will be like, hey, everybody out there is using JQ. We need to roll a version of JQ into apt so people can grab it easily. And I could say JQ. Let's see if it has a version. Yeah, JQ 1.6. I don't know what the current version is of JQ out in the wild from the official creators of it. It might be 1.7 or 8 or 9. It tends that the distro versions of things are slightly behind. And so it's important to know that. So there you go with apt in the Ubuntu world. Let's exit that. So now that I'm out of the container, that container is gone, completely gone. All of the software I installed, gone. None of it exists anymore. I could bring it back, but for our purposes, it's gone. So I'm going to use the up arrow keys again, and I'm going to go and use CentOS now. So I can just say CentOS, and this is probably going to run 8 CentOS because it's going to pull the latest version now. Cent 8 is the definitive version, even though it's going to have a shorter lifespan really than 7. So the CentOS latest container, 4.19 is the kernel version. So in this world of Cent, Yum is the package manager of choice, and I could search Yum. And what it's going to do is actually go out and automatically find and fetch the remote directories of packages. So I don't need to do like a Yum update to refresh my lists of packages. Yum update is actually a different command. Yum update will update the packages installed in your system. And I should have said that with apt. You can apt update to refresh the lists of everything and see if any upgrades are available. And then you can do apt upgrade, and that will upgrade all of your installed packages. You could do them one by one if you wanted, or you can just do a bulk upgrade. But here we have it. We have JQ in 2 forms, and it's going to pick the right one that we need. So we could say yum install JQ. Boom. It tells me what's getting installed. So it's installing JQ and Oniguruma. Don't even know what that does. It comes from the AppStream repository, which is the canonical CentOS. Upstream, you can see that it's going to deflate out to or inflate out to 1 meg. So I can say yes for that. Here again, I'm getting a prompt. So I was getting a prompt for, is this okay to install it or not? And then part of what it needed was a signature to add this key to my list of accepted keys. And so I'd have to accept this or not, yes or no. So I'm going to actually fail that, and I'm going to say no. And just for sake of example, show you again how to do this non-interactive thing. Same thing in Yum. I can just say -y, and this is going to basically just check affirmative to any interrogative sort of prompt. So there we go, all through. It got both libraries, it expanded them, and it installed them. Installed JQ and Oniguruma, and now I could use JQ and I get the prompt. So that's perfect. So now I can, yum install htop. I can do lots of libraries if I want. I can do zip and unzip if they're not there. I could do, Python 3, and it's gonna, aha. So here we have it where yum doesn't know htop. It might go by a different name within the Cent world. So I'd have to go maybe Google around and find out what that's called. For the meantime, I'm going to just get rid of it. And it's going to say, okay, well, so Python, for Python 3 and zip and unzip, as well as these other dependencies, it's going to be this much, and say yes or no. Notice Python as distributed by the Cent world is going to be 3.6, which is fairly behind. That's okay in my book, but you might want to kind of push it a little bit further than that. But there you have it. I mean, basically we have the same sort of thing. It's really comparable to yum, to apt. Sorry, yum is. So I could say yum search, search for MySQL. And here's the client program, the common and developed versions, test versions, the Python 2 and 3 PyMySQL libraries to help integrate. Which brings us to another thing. Sometimes you might be working with Python and you're probably really used to using pip, or you're used to using pip env, which is the newer mode of installing library dependencies. So pip install, 3 for Python to work with AWS, or pandas, things like that. There are some times when you need to install a Python library using a package manager instead of the pip method or the pipenv method. And this is just because of particular quirks of particular distributions and how they've chosen to solve that. I like it personally when it's just based in the language and you can use pipenv to install all your libraries and you don't need to touch the package manager. But there's sometimes that you just need other dependencies that aren't part of the pip universe. A case in point is when you're doing secure transactions over the web or talking to a remote API that's secured. You're probably going to need OpenSSL. That's installed by default in a distribution or in a container. So you might just need to install that as a package, using yum or apt or whatever. And then you can go ahead and use pip to install the Python package itself that requires OpenSSL. So that's that version. If I wanted to upgrade the system, I could say yum upgrade. It's going to tell me everything that's ready to be upgraded. 25, 26 packages. I could say yes to this. It's going to tell me all 51. It's fetching them right now. It's running and installing all the scripts for each one, and it's kind of giving me a status. There are actually 76 things to do. There they are, all installed. This is a regular sysadmin task. Doing a yum update and a yum upgrade. In yum, it would be just yum upgrade. And this is something you do not want to do by hand. It's not really worth the time. So this is where we use a tool like Ansible or Chef or Puppet. There's other tools out there that do this, but these are basically change or configuration management tools. I'm a fan of one that doesn't require an agent to be running on the hosts themselves. Ansible is nice because it's sort of pushed from a central node. You have what they call playbooks, and you can say, hey, Ansible, this play defines what state I want my instances to be in, and I'm going to define for you the list of instances I want you to hit. You can give them a name of a group like web hosts or database servers or whatever. And you just declaratively describe the state you want. You're like, I want this package and that package. I want you to remove this text file. I want you to modify, chmod this file, create this new path, mount this NFS share, whatever. It could be tons of things, all sorts of plays for every sort of operation. And then Ansible will one by one go out and hit the node SSH, remotely shell into them, make them conform to that state, and then you're good to go. So if you have a fleet of 40 nodes, 100 nodes, 5 nodes, Ansible is just going to hit them one by one. You can tell it to do them in bulk. You can do them in rolling updates. You can tell Ansible to pause 30 minutes between every node. And that way, if you have a really large cluster, you could just sort of roll through it one by one and make sure that they're all conforming. Now, the even better way to do this in Amazon or in GCP or Azure is, instead of taking a node and keeping it around forever and keeping it healthy and upgrading it and patching it and all of this, not just kill it and bring up a new one. And part of the process of bringing on the new node is that it builds itself with all the current versions of your software and all the packages it needs and the current OS and all the security updates and everything. Remember, it's cattle, not pets. You don't want to keep this thing around for years and years and give it a name and maintain it carefully. You want to just basically use it while it's usable. And if maintaining it becomes a little bit more work than creating a new one, then just terminate it. Bring up a new one, or better yet, have AWS automatically bring up a new one for you that bootstraps perfectly. Okay, so that's our Yum universe. I'm going to exit out of that. And then our final one is going to be the Alpine distribution. And so I'm going to say Alpine, and now Alpine doesn't come with Bash. It comes with just the standard shell. Really nice little prompt there. And then I can just say APK Alpine package K. And then I just want to add something. So I want to add JQ. I can just say APK add JQ. APK add Python 3, because that does not come as part of the APK container. And when we talk about distribution sizes, you download Ubuntu, I bet it's, I don't know, 300-400 gigs. Sorry, megabytes, not gigs. Let's go take a look at that actually. Let's see. So we'll say Docker images grep Ubuntu. Okay. So no, I was wrong. It's not that much, but wait till you see Alpine. So Ubuntu 20.04, which is the latest, is 72, 73 megs. But remember, that's stripped of most functional software. You're going to be installing things on top of it. So in the Docker world, they keep it very trim. If you downloaded the medium for this, it'd probably be a couple hundred megs. 1804 long term is 63, and again, that's stripped out of everything. But now if we go ahead and get Alpine, you'll see here the newest version of Alpine is 5.6 megs. Really nice and tiny. If you want Python 3.8.8 distributed into Alpine already, that's 42. So it's still considerably smaller than your other base images. So that's why Alpine's really useful. It makes nice, tiny, light, portable containers. So if I run that again, clear this, APK, add JQ, add HTOP, it's going to give me all that. I can use HTOP again, and so on. So it's meant to be real clean, very expeditious. And so, yeah, there you have it. If you were going to be installing remote software more, you might want to install curl or HTTPy or wget. Oops, it's not the install command. It's the add command. So there they all go. And then I could curl for, anything I want. Curl for Google.com, and here's all the JavaScript for the main page of Google. So that might be a way I could go out and fetch remote software from a vendor. Honestly, you guys, some of you might early on in the course think, oh, but I'd really like a desktop. I'd really like a GUI here. GUIs are nice. GUIs break and cause a lot of problems. So there's a reason why production hosts, even in the Windows world now, don't really have desktops unless you want to add one specifically. that whole overhead of running, X Windows and everything on top of it and GNOME or whatever, is just, it's a heavy burden that you really don't need. If particularly if you're not really in the business of shelling into these instances and using them interactively, if you're just kind of always injecting things from afar or bootstrapping them upon creation, or speaking to them over APIs and things like that, you don't need a desktop. We'll disabuse you of that need as we go. So anyway, thanks for watching this. Hope this was useful. Bye.